Hey, who's all here? It is Monday afternoon. It's 1 p.m. in Knoxville. But who do we have in the chat? Let's find out. If you're here, say hey, and we can start working away. Start looking at, do some R coder here. Let's go check out some R stuff right now while people are just hanging out. Let's do it. It's Thanksgiving week, but we're still working away right here. I'm going to have the holiday here soon. Get some ham, get some turkey, whatever holidays you celebrate. Riley, great to see you. Ask some questions, Riley, if you got them. Let's throw out some 100 points right here. I think Mewbot's awake. I was trying to program him this weekend, and he said no. He said, nope, not programming me. He breaks the world. You get to see my green screen. Let's see right here. So one thing, I don't know if anyone from 320, 474 is watching, 475. There's this, there's all these packages, GG Ally and GG PubR. Really great packages. And I was like looking what's inside of them. GG PubR is such a good package. But if you have questions, let me know. We're just kind of free-flowing some stuff right now and just checking out. There we go. There's all that. And you can take a look at what's inside of these with the GG Ally right here. Yeah, look at all the GG Ally. There it is, GG Ally. I think those are ones I use. GG Ally. No, GG PubR, I think. GG PubR. Where's my GG PubR? GG PubR. Now, what is GG? GG is a way we make graphics, and it's really easy to make like GG graphics with these, like a GG scatter plot right here. So we're going to load up some data right here, and I believe we need to look at the GG scatter code, and we can take a look at any code we want with going to the question mark, and it'll show us how to use the code. So it says we need data, comma, x, comma, y. That's the format we're going to put it in. And you can see right here, someone does the format down here, and they do all the pretty things. So let's go take their code, and we're going to put in survey 10. We're just taking their code, and this is why copy paste is the best thing. We're going to use the x variable of weight, and these are variables inside this data frame, just kind of like what you would see inside of Jump. When you look inside of Jump, you would see data inside of it, and let's go here to global environment, and you would see like height and weight. So this looks like a Jump or Excel spreadsheet. So all we're doing is switching the name of the data frame we're using, and then we're changing the names of the variables, and we should get it. It says unknown color. So they were using a color right here. Oh, so we could go to gender for the color. Well, here we go. Let's find out if it works. Finding out. Oh, whoa. What are all those name things on here? What is the name thing? Whoa. It's looking all crazy like. We need to remove that, but we actually got a trivariate visualization right here because it's got height, weight, and gender up here at the top. I need to remove this whole name thing. That's not, I don't like that. There's the palette of colors they're using. Repel equals true. Let's put that whole label equals name. No, there's where that's coming from. So we need to remove this argument right here with the whole name. I don't know what the argument repel equals true does. But let's rerun this again now. Now it looks better. We got that whole name thing off of there. And let's go here and do the following. Let's pipe it through ggplotly, and let's cross our fingers here, because if it works, it'll make a really cool graphic. Yep, so now we get a plotly graphic, which allows us to hover over and actually see the data points. So now we can actually interact with it and actually, figure out a point. You could even zoom in on some areas of it and see certain points a lot closer. Like if you wanted to go to this person right here and learn more about them, you can just hover in and you've got an interactive. You can take pictures of it, all these different things, download as a PNG. You could screenshot it, but we've got an interactive graphic, and it was pretty quick and easy to make. You can turn on and off points, which is really awesome. So you could look at just the male distribution right there. You can turn off all the points, go back to the female distribution, and look at the scatter right there. What I'm wondering is if we can make the line plot for it. I don't know if you can add a line. Let's go look at the arguments on this. So if you have questions, let me know. I'm just kind of showing maybe some 320 relevant stuff right here. We're back in the looking at how to use this portion of it, and there might be an argument to add a line. GG theme, nope. GGP, no. Bunch of correlation stuff will be added to the. Oh, we can add the correlation coefficient to this. I don't know what it's going to do with two of these. We're going to move off the ggplot for a moment, but we can add in a correlation coefficient. And now we get the correlation coefficient, that the correlation here, which is kind of nice. Maybe you need that in your reports. You can get a correlation coefficient with a p-value added to it. It's pretty nice, pretty nice. So that was correlation coefficient. Parse, expression display, just no, we don't want that. Label, rectangular, repel, word used to repel to avoid overplotting text labels and whatnot. Oh, that's what that is. We had the repel equals true on. Font label, I don't know if there's a way to add a line through this though. Let's find in topic, line. Oh, right here, add regression line. And add a Los line. Will it add 2 regression lines? Oh, this is super cool. So we're gonna add to it, and these are multiple arguments you can add right here. Shouldn't probably add all of them. That'd be a little ridiculous. Los is the least, what is it? I can't remember. Local estimates. It's local estimate. Yeah. There. Wow. It actually did it. It actually made. This is super cool. Wow. I didn't even know you could do this. And then let me see what happens if I run this through a ggplotly right now. I just learned something. It actually made indicator regression. Let's send this to Dr. Petrie. Let's remove off that correlation coefficient because it's getting super mad about that. We don't want that argument on here anymore. And now let's go right here. And we actually get... yeah, so if you have questions, put it in the chat. Let me change from top chat. But I want to send this to Dr. Petrie now so he can take a look at this. Really good indicator regression with the 2 lines. I don't know if we can do an interaction on this, but I've had trouble with getting a ggplot for indicator regression. So indicator regression is when you include a categorical variable. My 320 should know this. And what's really cool is we could take a look at just like the... I wonder if I can change the colors of the lines. I'd like for it to be like a black and red line. I don't know if there's a palette for line colors. Add params, add params. The add, this might be where the line colors are at. That, so many different things. These are all the different things you can change right here. I'm trying to think. I don't know what the add dot. Let's try it. And let's go to a palette on it. And we're going to change the palette. So we'll do a palette as a list, and we'll put the only argument in here as a list. And we're only going to put in 2 colors because it might be add parameters, like parameters for the ads, like the ads parameters. And so if they're really smart, so we're going to do FF8200 and FF. If this runs, oh, I did the question mark. I was mad about the ad. It's mad about the ad params, I think. Oh, and then I didn't put a comma. This is why we do code in parts. It didn't do it. If you have questions, let me know. We're just kind of trying out new things. Trying out new things right here. Seeing if we can get them to work. ggpar. What does the add params do? I have no idea. Oh, wait. Here, someone's got it right here. Color. Is it color? Color? Oh, it says no. Add. I'm searching over here. Add.params. Yeah, no, this is what it uses. List. They're using the add.params the way I'm using it. I'm concatenating it. Try one more time. I'm going to literally take the argument. Just going to drop it in. They have 2 things. Let's just run it. Unexpected. Regline. Let's see if I can say anything. What do I have? What did I change while I did this? What did I change? It's mad about something. So this runs, right? Okay, that runs using, that's fine. And then I thought, oh, this is, okay, that's got to be right there. I think I didn't. Okay, that's got that. Okay, that did something. That did something. That changed the size of the line. Let's go here. Okay, that is, yeah, we need to concatenate a vector on this now. So let's go to list. Let's open that up. And call equals concatenate black. Let's go classic red right here. And let's go size 1. It might apply for both. Oh, wait, what? It's the same as the data. Is it mad about this? Oh my gosh. Why is it mad? We've got 2 lines. It would make sense. It says aesthetics must be length 1 or the same as the data. 80. Color and size. So it's mad about the color. So that gets us 1 red line. We're so close. We're so close. So close to what we want. Just trying to have it add 2 lines. It says it needs to be the same size as the data as 80. Well, then let's have it be 80. Rep black 80 times. It does work. It does work. Okay, let's try this. Let's rep black 40 times. And then let's rep, go to the second element of this, rep red 40 times. It works? Ooh, that's interesting. It's like how many times, but it's making 1 line. It's kind of cool. It kind of shows you how it does it, that, you know, you could do a different length. Really not that good for us, but now we can change the way it's drawing it. So we understand what that's doing, but we're not getting the 2 lines. And so it's not achieving, we just don't have 2 lines. We have 1 line for the data. And that's where we're running into the problem. So I don't know if I can get it to do, I can use the default, but I don't like that the colors of the lines are the same colors as the point. That's a little hard to see. Like aesthetically, we get the 2 lines right here, but then it's going back, and then when I do the add parms, it's doing it, like add Parmesan to it or something. Yeah, that's, I don't know why. Yeah, it's like, I don't know if anyone's ever asked this on Stack Overflow. Let me see right here. Let me go over here. Go to Stack Overflow and find out if someone's asked the question. So GG scatter 2 lines, different colors, Stack Overflow. We're just kind of having fun right here, jumping some questions. You got it. Color by using a group and GG scatter. That's not what we want. It's not what we want. Nope. GG scatter for, oh, Connor. Yeah, check it out, Connor. I'm so close. I've got this right here. I'm trying to make some indicator regression, and so I've got that, but I'm trying to have it do 2 lines. But when I go to the add parameters for the, I think it's the add argument, because I added a reg line. Maybe I need to do it after that. So I added in this, and good to see you, Connor, here. Excellent stuff. I did this add parameters as a list right here, and maybe if I put in the second, but I can't get it. And I'm using the package ggpubr. ggpubr, such a good package if you haven't checked out ggpubr. But I'm so close to getting this to run. That should still run. Okay, that runs. Maybe if I do 2 different sizes, but it wants the vector length of like each argument is inside of my list right here. So rep, oh, this will be really weird. It's gonna like, I think, change size. Rep 260 times, and the second argument here is rep 120 times. So that'll work, and it changes the line size right there. So it's treating it as 1 line is the issue to me. Does that make sense, Connor? Like right here, I've got the add regression line, which apparently you can do LOS too. I wonder what's happening if we do it the LOS regression. Oh, there it is, LOS, least, or local optimized, local estimates. So, but if I remove out the add parms, every time I hear it, I just feel like I'm adding Parmesan to this. Let me go over, well, I need the pipe through the dplyr. So let me comment this out. We'll take off the add parms, and we'll just remove, well, then we don't want the last argument. So that should read through, right? And now we get, you see, the problem for me is right here that you can't really see very well the lines. So I'm trying to change the colors of the lines to not be the colors of the points. So the palette we're using right now is for the points and for the lines themselves. But when I try to change the colors of the lines using the GG scatter, which is in ggpubr, does that make sense, Connor? So I thought the add params would do it, but can't add parmesan to everything. Params to everything. Star plot? What is a star plot? I should know that, right? Let's go ahead and look through the line again here. So there's the line we're adding. Size. Talking about the regression line, linear regression, local, there it is. Local regression. Yeah, it's just local regression, right? Could you pass its stats line to the equations of the groups? So pass stats lines. Are you saying a totally different equation? Oh, wait. Was they doing it there? I might like just need to use, I'm trying to use the quick and simple way of doing it. I think it may like overly complicated. It's like so close, so close. So we don't need repel if we don't want, we don't have text anymore, so repel doesn't matter. So I might just do, what is the argument again? Reg line? Yeah, exactly. Like, there it is, reg dot line. Yeah, using this package is supposed to make everything simple until we made it overly complicated. It's just that when we add the parameters to this, well, we've got why do we have 3 palette? I think the original thing we stole this from had 3 palette. Might be part of the problem. Let's go ahead and add the parameters now. That might have been the problem. Now we need this is an additional argument here. I think we're good. It just keeps switching it back to one line. It considers it like one group of data and it's using the equation for the one line. And that's what gets, if I put in 2, if I just like make it simple and put in like 2, it'll say like, no, you have to use the same. Like if I take the reps off of here and just put it to black and red, instead of it being like, oh, you want a black line and a red line? It's like, no. You have to have the same length. And it says right here, you have to have 80, because it's using like 80 points connecting through. It's using 80. I guess there's 80 unique observations. I bet you if we did this, what's the X variable here? Weight. I bet you weight. I'd bet good money. Unique survey 10 weight. No, it says more than 80. I thought it would have 80. I should have done length on that too. You would have to use the ggplot on the data, so just use a ggplot of it. That'd be easier. And then use geom point. So yeah, so let me practice my ggplot here. You ready? Let's practice some ggplot. Oh, I've been using my gg scatter too much. Okay, so when you do a ggplot, I gotta practice. Okay, there we go. We got the data, we've got the mapping is the aesthetic where the x and the y will go, and then we'll add a geom point to it, and you just do plus geom point. Okay, it's not too hard to use ggplot, right? So the data is going to be survey 10, and we're gonna go here to aesthetic, and then inside of aesthetic, there we go x equals, we'll just grab our x and our y right here. And there's our aesthetic, and then we're gonna go to plus, and we're going to geom point. Woo! What did I do wrong? Height, weight. I've been using too much of the easy stuff lately, Connor. My ggplot stuff is off. This is good practice for Brian right here. So survey 10, aesthetic, height, and weight. We're just getting the 1 point. Let's add a geom line to it anyways while we're at it. No line. There it is right there. Aesthetic, color equals steel blue. Geom line. Oh, wait, I thought you just do the geom line on this. I thought you do the ggplot and then you add the geom line. So, because you create this right here with the aesthetic, right, Connor? We've got the height and the weight. So what have I done? improperly right here. ggplot, scatter plot, stack overflow. Need to plot, check my ggplot syntax. ggplot, aesthetic, x equals that. That's the way it should look. Oh, then do this right here. Okay. Okay. Yeah, you're just saying just grab this and then do the aesthetic inside of it. Okay. Let's do that. So there's the ggplot, survey 10, capitalize. Then you're saying take the geom line and throw in. Do we throw the data again? Can we just throw in the aesthetic? And then let's run the aesthetic up here. What's going on, Connor? Watch this. I'm going to super cheat. Okay, wait. Fun with data. So ggplot, scatter plot example. Here we go. Let's go grab it. Regular old scatter plot right here. That's why I use ggpubr sometimes. Makes life so easy. Oh my gosh. Do you know what it is? It was seeing it as words. Love it. Absolutely love it. It was seeing it. It was seeing it. Oh, great to see you here. It was seeing it as words, Connor. So now we got when we need to add in the method equals los, right, or something. Method equals los. Local optimize regression. Local estimate. Is it not? We're getting there. Geom line. I had them in as strings, and that was the issue. We were just practicing coding. Was it not going to be our los? I would just leave the data in because I think it would have to use dplyr to pass the data frame. Yeah, I think so too. And so it should be passing through right here. So mapping null, data position, rounding. What is going on? Geom point. Geom smooth. Geom smooth is what I think we want. Let's go grab. There we go. Now it's using los. And we can switch it to LM. There we go. Okay. We're good now, Connor. So now we've got our regression. Do you want to watch this, Connor? You probably know this. Plus GG title. GG title is in ggplot2. You probably know this about like height versus weight. But did you know the following? Plus, do I have it on? Easy. No, I don't have it on. This is where I'm doing things I shouldn't do because we'll put this on a separate line. Library GG easy. Easy center title. And look at that. That's a new trick that I learned lately is the library GG easy has an easy center title. So if you add a title to something, you can just go easy center title takes no arguments and it just centers your title for you. So apparently, you know, it was a lot more code to get the title centered. You had to change. Yeah, I know the GG. I'll have to look more through GG easy, but when I found GG easy, I was like, that's awesome. It makes it nice and easy to center that title. Just run the argument easy center title. No run the function, I should say. No arguments inside the function. And yeah, so okay, so now we're trying to add here like a color, right? So we want another aesthetic, like color equals gender. Okay. Now let's take our whole thing right here and pass it through a ggplotly, see if we get similar. Maybe we should just build this all from scratch, right? Maybe that's the theme. It's like, don't go for the easy. Okay, this is looking better than what we got previously. I want to change the color of the lines, though. So this is where the lines are being created. The points are being created here. So could we go to color of the points and concatenate a vector and go to like red and black? We're just going to try this out. Oh, it's mad. Mad about that. The sex must be the same length. Oh, you put it on Discord, did you? Did you message me? There you are, Damaro. There you go. Oh, you got it? Oh, can you copy paste this code in? Wait, here we go. Geom data color equals this, color equals red. Oh, you're doing 2 geom lines. And so you did 2 geom lines, geom point. Mint cream? There's a mint cream color? What? Okay, so wait. You're doing 2 geom lines. And so you've got here, but you're doing 2 different Ys, right? You're plotting 2 regressions on one plot. So here, let me walk through this. Yeah, see, I should know, like, mint cream. I didn't even know about that. But you're doing 2 Y variables. Like, if we wanted to go here, and I'll show it, and great stuff right there. So you're starting first. Let me look at the code again with you have right here. You're starting with the ggplot. I'll mimic what you're starting with the ggplot, taking the data frame, and well, I won't use tornado. I don't have, well, tornado I should have, right? Is it just a base R function or base R package? Tornado. I don't have it. I do not have that data set. So you're taking that, and then you're adding on to this a geom line. So we're adding on a geom line. You're passing through the data again, which should just be the first argument. And then you're putting on an aesthetic to it of the x equals like height. We're gonna run out of room here. We'll go sub indent so we can view it all. I don't like that. We're gonna move the plot for now. And then we put a second argument, weight, and then you're doing outside of the aesthetic. Now, why would we do this outside the aesthetic right here for the color equals like steel blue? And I'm going to run this. This should run, right? Okay, that ran. Okay, so that's got that. And then you're adding on to it another geom line. And we have color equals red. And let's just do here like, well, we want to use the same Y variable, wouldn't we? Because it's going to, let's find out what happens. Whoa. Whoa. Cool stuff right there. And then we're just making a fun plot for the heck of it. And then we'll add on geom points. Your geom points are using the same things, just with the geom point. So let's take both arguments right here and go and change this to geom point. I think you're using the same. Sorry, I'm looking at the code and screen. And then, oh, you did the theme. You added on the theme, which automatically runs for you. Theme modern. I don't have that theme, so I'm just gonna. Is that under GG themes? GG themes. Theme modern. I don't have that one. Let's go. Sure, let's run that and see what happens. Does it run? Oh, cool. Let me go look at what you're saying, Connor, or if people have questions. Howdy, Adam. Yeah. Is this HRBR themes? Have you know officers, chapter 19? Let's do some chapter 19 here. We've been having some fun here looking through this code and kind of making some neat graphics. So Connor is, I don't think I have that package. Let me see if I have it first. Do I? Oh, I do. I do have it. So Connor was suggesting the modern RC theme. Theme, modern RC theme. Oh yeah, I've seen you. You use this one a lot. And so we get this plot right here. And then we can add to it a title plus GG title. And let's just say randomness. There we go. And then plus easy center title. And there we go. And last but not least, we take the whole thing, all of our fun today, and we put it into a ggplotly, and we say, please ggplotly, work for us today. And it does! So this is just a fun random graphic we've created right here. We're going to do some chapter 19 in a second. But, oh, is it loading? I don't know if it's loading or not. Pretty crazy right here. We could change the method by which these are creating. But Connor, thank you. Good practice right here. Getting everything to create totally different scales on the variables right here and the different plots. Yeah, so getting, oh, you see like here it says height, but, oh yeah, both x's are height. But this is not weight. There's another variable down here. But we could zoom in on this. We could take a look at this data right here and actually see what's going on with this data and take a look. But no, that's some good stuff right here. We'll do some chapter 19. So thank you everyone for like hanging out here. GG Smooth, Geom Smooth. Yeah, we want to use the Geom Smooth. Let's do that really quick. So instead of the Geom line, let's go to here, Geom Smooth. It'll use the LOS method. Oh, no. What a thing do I have there? I don't know. That's something saved or something it looks like. And yep, there we go. So now we get a smoothing pattern through these, and we can actually take a look at it. We've got 2 random plots on here, but we are just kind of creating some graphics, looking through. And then we can change. Yeah, let's go do that. Instead of using the default method right here, we want to go all the way to the very end of this and go to method equals, and LM, which stands for linear model right here. And there we go. And that has created 2. If you want the points, different colors, yeah. And then the lines, and then go to add line, and then on top of those. So that should work, right? Yeah, so basically, but you know what you might have to do? Well, the problem is you might have to like subset your data with this. Like you might have to subset, like if we're doing like males and females, you might have to subset males, subset females. Does that make sense? So I think we might have to subset it, Connor. Like to do this, we'd have 2 different subsets, or pipe it through and do like a filter on the dplyr, like filter the data into each thing. If you want, yeah, we should take a look at this. No, great work, Connor. This is a lot of fun right here. I love like practicing and just, yeah, to have to subset it probably, and then create one group this, one group that, create the line for that, create the line for this. See, I keep thinking about updating reg class so we can make much cooler graphics, because I think it'd be way better in reg class if we could just like have a function that did this for us. Like when you do your visualize model, like right now our visualize model doesn't make graphics like this, but why can't visualize model do this? Why can't visualize model make a really nice like interactive graphic where we can see like the outliers to the model? Let's hop back into the main screen and do some chapter 19. I love that kind of stuff. I love working with data right there. Helen asked a great question. Have we done the chapter 19 homework? Let's go do that chapter 19 homework. Helen, thank you so much for swinging by here. We're going to do some chapter 19 homework. Let me close out of R. You got to practice these things. You got to, it's all these different things, like different skills. So I love sitting down sometimes and just like trying to work through and solve these things. And you run into problems. Your data is not going to work out each time. And then you have to like know how to write the code. It's just like a quiz. And Connor is practicing his skill set up. That's what we like to do here. Practice, practice, practice. If you don't use a package for a little while, your brain will be like, wait, how do I use that package again? You ever have that, Connor, where you come back to a package where you're like, you haven't used it in like 6 months and you're like, wait a minute. How's this argument work again? What's it take? What's it do? Question mark. I'd be pretty certain. Luckily, a lot of things we use are consistent, a lot of base functions. We are pulling up the homework here. We're going to work on some chapter 19 homework. Let's do the whole homework. A lot of people working on that lately. We're going to be doing some chi-squared test of independence. You could use the fill argument. Oh, yes. Chapter on question 4 of the homework at the moment. Question 4? Let's go straight to question 4. Helen, thank you so much. Hopping into question 4 on the homework. We're going to go in backwards order. Let's go through that with the code I sent you. Yes. Oh, yeah. Fill for the argument for the ggplots. I'll look into that. I love it. Let's go do some homework. Chapter 19. Here we go. So what kind of test are we doing here, Helen? What kind of test are we doing? When we do the chi-squared test, it's known as the chi-squared test of what? The chi-squared test of this, which is the null hypothesis between the two variables. Like we have here gender and someone's political affiliation. The null hypothesis, probably next thing we'll do for this, is going to be that the two are what of each other. So we are doing the chi-squared test of, if you remember the name of it, you remember the name of the null hypothesis. Independence, great job right there. The chi-squared test of independence, 100 points in the chat. Chi-squared test of independence, and that's the null hypothesis. Now, what does independence mean? It means if you know one thing about somebody, you wouldn't know any information on the other. Like knowing someone's political party would give you no information about their gender. So we've narrowed out. We know it's not this choice. That's a wrong choice because that's not the null. The null is that they are independent, and the alternative is that they are not independent. I love the way this one states it. Sometimes they try to trick you or they change the wording. It should be known that not independent means the same thing as associated, dependent, or it would tell you information. It doesn't mean you know someone's political party by knowing their gender. It means, or political party would give you information about gender, vice versa. It means if you know someone's political party, You'd be like, oh, you're a Republican. Well, you're more likely to be male or female, whichever two up there, if there is an association. So this should be the null and alternative right there. The null being that they are independent, chi-squared test of independence. And then the alternative would be that they are not independent. Just put the word independent between the two of these. Now, the first condition right here is count data. What does count data mean? Count data specifically means that both variables are what? So count data means both variables are what? What do we need to run the tests in this chapter? What does the count data condition mean? To run the test, both variables need to be this. Both variables need to be what letter? Like they need to be this type of variable. So to run these tests, we need both variables to be what? Which we have someone's gender and we have their political party. For it to meet the condition of count data, both variables need to be categorical. So this is definitely a yes right here. Does that make sense, Helen, right there? If we meet the count data, it means gender is a categorical question, like it put people... It means gender is a categorical question, puts people into categories, and we got a cat in the chat right there. And then political parties, a categorical question, puts people into categories. So just both things are categories. Good stuff. Is the randomization condition met? Probably. They don't go into enough specifics. Watch out. This sometimes flips yes and no. They don't really go into enough specifics right here, but probably. Did we randomly select these people? Sure. Did it say we randomly selected it? I wish it did. Expected cell count. Now, this is where it gets a little bit tricky. Now, if you notice, there's the least amount of independents, and I think there's the least amount of males. It's hard to tell. Let's go take the data into jump and check this one. So I'm going to go here, and I'm going to slow down while I do this. Make sure to follow these steps. We're going to copy the data to clipboard. When we copy the data to clipboard, it's just going to bring it to a clipboard for us. Yeah, we could do that here. You bet, Brianna, definitely. And so let's go copy the data to clipboard. And so here's the data in the clipboard. We're going to hit copy, Control C. So now we've copied it. And now we're going to bring it over to jump. So once we hit Control C or Command C on a Mac or PC, vice versa, we're going to go over to jump. And then inside of jumps right here, we're going to go and we are going to go to File, New Data Table. You can be anywhere inside of jump. Just make sure to go to File, New Data Table. With File, New Data Table here, we're going to open up the new data table. Do not click inside of it. And then go to Edit, Paste. Ah, yes, definitely. We'll do that soon here, Brianna. You got it. Edit, Paste with column names. When we paste with column names, make sure you see the column names appear up here at the top. So now we just did Edit, Paste with column names. So we have all the data inside a jump. Now we're going to do one last step before analyzing. Go to Tables, Stack, and I'll pause right here. Yeah, I'll do it next. You bet, Brianna. Thank you so much. And so we'll do it and then practice. So we'll go to Tables, Stack. And with the stack, we're going to double click the D, R, I for Democrat, Republican, Independent. And now we're going to click OK. So this will stack those on top of each other. And here we are. So this should be our final result. This is not the result. You're welcome, Brianna. Anytime. 100 points, Brianna, there in the chat. So this is our result right here with the gender and political party and the counts of individuals. Now we're going to go to Analyze, Fit Y by X. So Analyze, Fit Y by X on this screen right here with the stacked columns. And now we're going to click inside of here and put somebody's label right here, somebody's gender right here, even though it's a little underscore. And then the data, the data is going to go down here. I'm going to pause, make sure everything looks like this. You want the two categorical variables in the X and the Y. Does somebody's label explain their gender? That is the gender variable. We could have renamed it, but it's fine. And this is the data right here, which is the counts of the individuals. So now we're going to go ahead and click OK. We get a contingency table. And with the contingency table, we can actually remove out. I'm just going to remove out everything but the count. We'll be adding stuff back in the moment, but I want you to see this. Wow, there's almost exactly the same amount of females as there are males. That was really hard to tell. It's oriented a bit differently, but that's fine. And there's the least amount of independents, as we said. So the smallest expected is this one. It's not because there's 17 there. It's because there's 105 females, making females the smallest group, and there's 44 independents. So if we click back on the red arrow and we go to expecteds, we will see the smallest expected total right here. And the smallest expected total. So, Helen, here's the big question. We did all this work to know that the smallest expected total needs to be greater than what? Which it is. The smallest expected needs to be greater than what? What must that smallest expected cell count be greater than? Which it is. There's the smallest, and if the smallest passes, they all pass. The smallest expected cell count needs to be greater than what? What do we need the smallest expected cell count to be greater than? The smallest expected cell count needs to be greater than what? It needs to be at least this, which means greater than this. The smallest expected cell count, which we went and calculated, it's right there. That's the expected right there. It needs to be greater than what? Which it is. It needs to be greater than 5. So we passed the expected cell count frequency because great job, Helen, right there. Excellent work. Greater than 5, so we pass it. And that is correct. There we go. Now it says find the p-value for the test. Well, it first says calculate the chi-squared. The chi-squared test statistic is down here, 11.744. Now, to get the chi-squared test statistic, you have to add up all the cell chi-squareds. So if you were to add up 3.48, 3.44, 1.09, 1.08, 1.3, and 1.3, you would get 11.744. So that is the sum of all the cell chi-squareds is the Pearson chi-squared test statistic. The sum of all the cell chi-squareds is the Pearson chi-squared test statistic. Really good bit of knowledge right there. It says to 3 decimals, and that's what we get. Does that make sense, Helen, how I got this right here? How I got the Pearson chi-squared test statistic? We might ask you to solve a cell chi-squared by hand. We went over that a lot during class today. But the Pearson chi-squared test statistic is the sum, and I'll show just the cell chi-squareds on here. Here's all the cell chi-squareds. All these numbers added up is 11.744. So you add up all those numbers, and you will get 11.744, the sum of all the cell chi-squareds, which is how odd each cell is. And then we just go and we look at the p-value associated with it. Well, the p-value right here is 0.0028, and that is the p-value. Remember, the Pearson has your p-value. If you're looking for the p-value, p-values are probabilities of our results are more extreme. Our result is the chi-squared, and a probability greater than the chi-squared is this right here. So there is the p-value. It's just the one associated with the Pearson chi-squared test statistic. And that's got it. And last but not least, we need to know this. Is that p-value high or low? Using a 0.05 alpha, which is when we reject the null, is this p-value right here high or low, Helen? What do you think? Is that a high p-value or a low p-value? Yeah. Which one? The quiz 9 diet question. Emery, can you explain? Can you go into a little bit greater detail the diet question? Which one's the diet? Are you talking about Canvas content quiz or which one are you talking about, Emery? Go into a little more detail, and I'll make sure to do that. And we're going to do 2 sample T after this, and then go into a little more detail, and I'll make sure to do that next. If you look at that p-value, is the p-value low, which means our results were unlikely? Or were our results likely? And if you look, Democrats are much more, I think it's odd. The colors are different than what you expect. Yes. So females had a higher probability of being Democrat, where these are more split, but are about the same, but more males. So when you look at this, the p-value here is low. So we reject the null. We have evidence for the alternative. So we reject the null. There is evidence to support the claim that there is an association between someone's political party and their gender right here. So we would reject the null. And why do we reject the null? When the p-value is low, we reject the null. Because we're saying the null hypothesis was not likely given what we saw. That's what a p-value tells us. Was our result likely or unlikely given the null is true? And our result was unlikely, so I reject what I currently believe because this is not likely. This big of a difference, or one more extreme, was unlikely given there's no difference between these. They're independent. And so this large difference tells me I have evidence of an association, that there is some sort of association between gender and political party. Emery, if you can go into a little more detail on that. Are you telling Canvas content quiz? And can you give me a little bit of the diet question? Or is this chapter 19? Is there a diet question for chapter 19? I think it's Canvas content, right? That's Canvas content number 9, I think. It's like talking about the differences between 2 diets or something, or like they make a claim about how much you can lose diets. We'll do that one next. Yep. Canvas content quiz number 9. Yep. We'll check out Canvas content quiz number 9 after a little 2-sample T right here. Thank you, Emery, for swinging by. 2-sample T coming up here in one moment. Getting it right now. Awesome. We're going to pull up some data. Let's go check out some 2-sample T. Let's go do it. So the 2-sample T test requires 2 variables. Now, it's not 2-sample because the 2 variables. It's 2 samples because there's 2 groups. Like, are you born in Tennessee or not born in Tennessee is 2 groups right here. But for extremely large data sets, oh, please message me about that, Connor. Please message me. Please, please, please message me about Feather. I need to look into this. I've been looking more into recipe. Have you looked into recipe much? I've been trying to get better about that. Really? Yeah, I need to look at that. Feather files. That's cool. It might be close to 0, Reese. It might be close to 0. It might be. Maybe send me a screenshot, Reese. I'll double check. But you can get very small. Oh, you said your chi-squared is coming up as 0. I know what the problem is, Reese. Reese, your chi-squared is coming up as 0. Here's why. So, Reese, this goes out to Reese real quick. Reese, go back to when you made the data. Not automatic recalc. I don't want that. Right here, Reese. I think you forgot the data. So your chi-squared, you forgot the data right here. You need the data down here, Reese. Does this make sense? If your chi-squared's coming up as 0, then you forgot the data, and your chi-squared will come up as 0 because it didn't get the frequency. So I assume you're seeing this right here, Reese. And so if you're seeing this, when you made your plots, I'm going to redo relaunch. You can get back to the previous screen with redo relaunch. Oh, great job, Reese. 100 points. Thank you for mentioning that. You just got to put the data right there. And there you go. And that will do it right there. So it's just a very common mistake. Don't worry about that. Great job, Reese. Excellent. Thank you for asking. Here, I'm going to do a new break in the video. Ready? We'll pause here for a moment because I'm going to put a break in the video to make sure when I tag these later on today. Oh. Last sip of coffee. This is all we got. It's mostly cream, but hey, that's some good stuff. That's all the coffee, but that's some good cream right there. 2-sample T, and then some Canvas content. Let's jump over to that 2-sample T. Good stuff right there. Test statistic coming up here soon, but 2-sample T first. When we do the 2-sample T, we need 2 variables. Now, what we need 2 variables for is we're going to have a categorical variable, like, were you born in Tennessee? And then we're going to compare your high school GPA. Now, we're going to compare the whats of people who are born in Tennessee versus the what of people who are not born in Tennessee. Finish Brian's sentence. A 2-sample T test will compare the what of this group to the what of this other group and look at the difference between them. A 2-sample T test, like we've got a yes and no group right here, we'll look at like someone's GPA from born in Tennessee and someone's GPA from not born in Tennessee and compare the whats for their GPAs. Like, we'll look at the whats for these people right here. We'll compare the whats of these 2 groups' GPAs. 4-letter word, like Mr. T. He's a nice guy, but a 2-sample T test will compare the difference between the 2 whats of these groups for someone who's born in Tennessee and not born in Tennessee. That's why it's called a 2-sample, because we have 2 groups right here. So why are we doing this? Our goal is to look at the what between these 2 groups, the difference between their, like Mr. T, 4-letter word. He is kind of... He's mean if you're doing drugs. There you go. Compare the difference between the means. Connor's practicing up, knows that 2-sample T test right there. And Connor probably knows we can do an ANOVA. If I want to do like repeateds. So we need a 2-sample group right here to do the 2-sample T. And great job, Connor, earning everyone some 100 points right there. So let's go right here and go to born in Tennessee is the X variable. Does being born in Tennessee explain someone's high school GPA? And once again, you want to figure out why this relates to your data. If you're doing something like this, explain to the reader those things. And let's go here and take a look. Now, this is a kind of like, almost like a scatter plot of sorts. We could add box plots to it if we want. Not the end of the world. They shouldn't take off points if we do this. Graders shouldn't be mean. Pretty similar. That's the grand mean of the data, which is the full mean right there, which is the mean of all the data. But let's go to the t-test. Here's the t-test results right here, and let's take a look. You definitely want to include anything you talk about. I might, if I'm doing this, I might not include the quantile report. I might just include this right here, but I do like that we get to see a little bit of a box plot to add some kind of context to what's going on, to where the outliers are, to where the median is, to where the high outliers begin, to the IQR in the middle. So with this said, what do we see right here? And this kind of goes to questions about t-tests and stuff, to Emery's question. We saw a difference between high school GPAs between the two groups of 0.045. That is the difference between yes and no. But who had a higher GPA right here? Now it's yes minus no. So that's very important to see, because whose GPA was on average higher, the yes group or the no group? So it's yes minus no. So think of like 10 minus 8 or 8 minus 10. If the difference is positive, which group had a higher mean, the yes group or the no group? Generally, questions on the test might look like this. Like, which group had the higher mean? Was it the yes group we saw had a higher mean, or the no group had a higher mean? Which group had the higher mean? And so the difference is positive. What does that indicate to you? The positive difference indicates, whenever the difference is positive, good note to take, is that the first mean was higher. So since we see a positive difference, it's like 10 minus 8, which would be a positive difference. Now, this isn't 10 minus 8, but just means yes group had a higher mean than the other group. Do not include this output. I'm just showing it to show you the means. We're not doing the ANOVA test right here. But you can actually get the two means right here. And you can see the yes group had a mean of, great job right there, Emery. Thank you so much. Do you see the yes group and the no group? If you mathematically take the yes group right here, 3.82692, and subtract the no group, 3.718 or 8122, you get the difference right there. Does that make sense? Like, this difference right here is the difference between the mean of the yes group and the mean of the no group. Like, this difference right here is the difference between these two means. That's what it means when it says difference. It's like yes minus no. 3.82 minus 3.78. That is that difference. Do not include this output. I'm going to remove it off the screen. It just shows you we're not doing the pooled T ANOVA. I'm not doing that test. Different type of test, different conditions and assumptions for the test. We're not doing a pooled T. Just shows you better output sometimes. So with this right here, that's what the difference is. Now, the standard error of the difference is how we can standardize that difference. And this kind of goes to Emery's question, because all we have to do you see this 1.6? If we take the difference right here, oh my gosh, and divide by the standard error, guess what we get? We get the test statistic. And I don't know if I still have this up from last week, but so how do I stay? Here it is. The difference divided by the standard error. The difference divided by the standard error, that's the difference between the two means, divided by the standard error is the test statistic. So we had this up last week right here, showing the difference divided by the standard error is the test statistic. So literally in this output, which we put it on the test, you literally just take the difference, divide by the standard error. These are the formulas for them. This is the difference. This is the standard error. And then you divide those and you get the T right here. That tells you how unusual your results are. Now from the T, we get the p-value. So these p-values right here are computed using the test statistic of 1.6, which landed right here. Better yet, is there no p-value animation on this? Oh man, they had p-value animations on the other ones, I think, but we can't get a p-value animation on this. That's a bummer. So using the test statistic, if we go above this to the right, that's 5.5%. If you double it on the other side, that's right about 11%. There's some decimal rounding going on right here. If you go below this line, that's 94.5%, as in we go to this graphic and we landed right here. Below right here is 94.5%. Now, none of these p-values are below 0.05, so we do not have evidence of a difference, which brings us back over here to the confidence interval. This confidence interval goes through zero. Specifically right here, this goes negative, which means it's possible that people not from Tennessee have a higher GPA than those, on average, than those who are from Tennessee. So the confidence interval, including zero, indicates to us the same thing as the two-sided test right here, which would mean we don't have evidence of a difference. So I am 95% confident the true difference between people's GPAs who are born in Tennessee and not born in Tennessee is between 10.1 points higher for those born in Tennessee to 0.01 points higher for those not born in Tennessee. Specifically, my interval contains zero, leading me to believe that there is possibly not a difference. Oh, Patrick, thank you so much, Patrick. I'm really glad. Yeah, what do you think about the project, Patrick? It's like a tongue twister. What do you think about the project, Patrick? It sounds like not too bad. I hope these videos really help out and kind of let you see how to read this output and what it means. Like, okay, this interval is trying to estimate really what is the difference. And then we see right here, the difference is estimated to be 0.045, but it could be as high as people in Tennessee, born in Tennessee, had a GPA 0.1 higher, or it could be people born not in Tennessee have a GPA 0.01 higher. This interval contains 0, so I don't think there is a difference because the difference might be 0. More specifically, I do not reject the null hypothesis that there is no difference. That's the null hypothesis. So the null being there is no difference is not rejected here because the p-value is high and also because the interval contains 0, suggesting that difference could be 0. Important to know what your output's showing and what you're testing with the 2 sample t. Thank you so much, Patrick. We're going to go back here. It was actually pretty fun. Oh, you're making my day, Patrick. Patrick, 100 points right there. Thank you so much, Patrick. I want people to have some fun with this project. Like, you have to do your own thing. You have to be like, let me just analyze some data. Let me just put it into Jump and run some code. Pretty fun right here. I like it. I like hearing that. I love analyzing data. We literally started this stream with Connor and I. Connor, do you like writing new code sometimes or trying something out? That's the way I am. Like, I get some new code or some new package. I want to look into this feather package, and you can check out recipe. Yo, Jacob, what's up? We're about to do a Canvas content question. We'll put those questions in the chat. We got some more office hours time. I like running new code. I like checking out new things. And it's pretty cool, especially when Connor's like, check this out, check this out. There's so many things you can do with coding, with programs. So it's really just like anything's possible, as a famous group one time said. Really good stuff. Let's look at this new diet question. Where is that new diet question? Canvas is being crazy. I know. I spent weeks learning ensemble time series models. Yeah. There's so many, like, it's all about, once, you know, you get a job or something, it's all about, like, what do you want to learn? What do you want to do? I do like to read psychology reports in my free time, which just, yeah, especially when you see p-values and stuff. Yeah, this is hopefully helps out with your understanding of like the psychology reports you're reading. Real yo from the real Jacob right there. Selenium in Python has automated a large portion of my work, so I need Connor, send me info on that. I've got winter break coming up, so I've got time to learn. I've got time to learn and grow. And Connor, let me ask one quick question to Connor. Do you know much about version control, Connor? Because I really think we need to implement that, and I might move everyone over to like Jupyter Notebooks. Really quick, Connor, and throw your ideas on this in the chat. Version control, Jupyter Notebooks. Don't they have a way to do RStudio? Brianna, great to see you here. Ask those questions in the chat. We're about to do Canvas content number 9, some t-test stuff, and we'll take a look at it here. I'll get the question ready. Drop your thoughts on that, Connor, in the chat. I need to talk to Nick again. I haven't talked to Nick in like a year now. Oh my gosh, it feels like yesterday I was talking to Nick, but Nick is a wealth of knowledge. Nick Brown, great former student who teaches me things. People go out there and learn things and start coming back and telling me, hey, Brian, you should learn this, you should do this, you should implement this. Always bring those ideas to me because I'm going to be looking into Feather and stuff like that. I'll let Connor put his thoughts in the chat right here. Thank you so much. We're throwing, you know what we're doing? Don't tell anyone we did this. But we're throwing 500 points right here for Connor swinging by. Everyone say, what's up, Connor, in their chat, or yo, Connor. Let's head over here to the main screen. 500 points in the chat. Let's do this. Okay, we've got a t-test question. So a new diet is being tested. I miss Connor would come by office hours and help people out. He'd be solving this question up on the board and being like, hey, Brian, is this right? And I'd say, yep. And he'd be helping out some Stat to 1 students. Huge thanks to Connor right there, who's also one of our, he helped out and ran Stat Lab online when we went online a year and a half ago for the first crazy semester. You know what I'm talking about. Okay, so a new diet is being tested. The vendor claims 10 pounds are going to be lost. Yeah, 320. Drop a 320 question in. I'll be doing the video later today. I meant to do it this weekend, but I'll be doing the video later today for the activity. But drop a 320 question, Charlie, anytime. So they claim 10 pounds can be lost. That is the hypothesized. They're saying, I claim you can lose 10 pounds. Well, okay, sure. After 6 weeks, 25 people are randomly taken to do the diet. That's the sample size right there. Researchers are concerned about this claim being exaggerated, which means we probably want to look to see if there's evidence that people don't lose that amount of weight. So the null is we assume that they're telling the truth, and we want to show evidence as researchers that the truth is less than that. So we're trying to show evidence that the true weight loss is not as high as they claim. The sample yields an average of... So people lose a little bit less than a pound. That would probably be a good idea. We should probably have people make repos or something like that, right? Repositories. Yeah, I think that might be a good idea. Connor, we should have a conversation about this and talk about where... Imagine if you had a whole repository of all your work from like 320, 474, and all these different things over the years. That'd be amazing. That'd be great right there. So this is going to be the sample mean. Sample mean because it comes from a sample size. And then this is sample standard deviation because it comes from a sample also. Yeah. Let's go check that out here next. I think that's next question. So, yeah, that's next question. You got it, Charlie. Thank you so much. And so let's go solve the equation. Y bar minus mu naught S over square root of N. And so we're going to take our Y bar. We observe not 0.9 pounds being lost. And then they claimed 10 pounds. Now, the big thing you got to remember is that the difference here is going to be negative. This is going to be a negative t-score. Whatever this t comes out to right here is going to be negative because they're well below the claim. So, yeah, Connor is a huge help during all the craziness. And so now let's go solve this. All we're going to do is solve negative 9.1 over, and that's 6.5 over, square root. Almost forgot that. Square root 25. So that's going to be negative 9.1 over 1.3, right? Double check our work. So 25 square root, and then 6.5 divided by 5, there's 1.3. And then 9.1, 9.1 negative divided by 1.3. Oh, cool. Negative 7. That's, I wonder how many, Connor can see his hours, but Connor existed well before we went to Mubot and everything, well before we got our class mascot, Mubot, who tracks all those points. But
I am Mubot.
Thank you, Mubot. You're always around, man. Connor has been around for, it's just, man, I just miss it. Yeah. There are two options. Configure Git to change the algorithm it uses, compare IPython-B files and use and replace the, yeah, I gotta look into that. Looks like Python notebooks or something like that. Looks like a Python notebook format to NDB-Dime, replace the no format with something else. Use the Jupyter Notebook, GPText. Do you use Jupyter Notebooks, Connor? We're going to go over here and do some regression after this. Do you use Jupyter Notebooks at all? Submit quiz. Type 2 error is when the null is false and we fail to reject it. Did we get it? We got it. 2 out of 2 points because we only did one question right there. I've tried using some Jupyter Notebooks. I'm like, maybe it's because I'm not used to it. I don't know. Let's head back here to the main screen and start doing some 320. Remember, drop those questions in chat if you got them. Mubot. Awesome. Great work right there, Emery. Emery, 100 points. Thank you for her hanging out, working some questions. We got open questions after this. We got 24 minutes left. Drop those questions in the chat. Developing an online course. What is this? I'm gonna sign up. I'm gonna look into this. I gotta do this a later time. I'll have to look into that. Interesting. I want to learn what's going on. Want to learn some stuff. I like learning. Do you like learning? I like learning. Let's go over here and check out 320. Charlie was asking assignment 11, question 2, A1, A2, also B1, B2. And so let's go check out assignment 11. Due on Wednesday with the activity. Big day Wednesday. Markdown file. We don't want the solution, do we? Oh, yeah, let's hop over here. Assignment 11. We're going to start off with A1, question 2, A1, A2. Let's go check it out. Now, it's really cool. I love our studio because you can just click right here and you can go over here. Connor, I got another question for you. I'll ask you later, but I always hate how all my data loads in by default a lot of times. I don't know. Need to fix my R. Mubot's always there.
I am Mubot.
He's abrupt today. Fit a regression model predicting quality from volatile acid and alcohol. No interaction. Examine the plot from the visualized model. Include the argument for the X limits and loc equals left for the location of the legend. The argument to make it look nice. I was like purdy. Focus on the plot on the right with the P value for alcohol. So we're going to go in here, save a model. That stands for M, stands for model. You can call it whatever you want, but we call it an M for model. GLM stands for generalized linear model. We're going to predict the quality of a wine. Now, I probably don't have the data loaded up. You're going to see here the data loading up somewhere here. That's the click data, and there's the wine data. You have to make sure you have the EX6 wine data loaded up. So I'm probably going to put it here. Doesn't hurt. But the EX6 wine data is loaded up. Tools, global options. Ooh. Connor, you are just the man. Tools, global options. Tools, global options. Where's global options on? Wait. And then, oh, there it is. Oh my gosh. I don't care. Connor just got everyone another 500 points. Everyone cheer on Connor. Connor's like helping me out. Connor, you learn so many little tricks, or sometimes you run into a problem yourself and you're like, I don't like that it does this. And then you just fix it immediately. Connor just, boom, solving problems for Brian right there, making it so his environment doesn't load up. So I was loading up my previous environment, but I don't like that. Too much junk. Don't want that. M save into GLM, and we're going to load the quality of a wine right there. So get some huge points. Connor just throwing down these huge points. So we're going to add in two X variables right here. And what we're predicting right here is a what type of variable, though? Quality of a wine, and we can take a look at it. Let's go here to plot EX6. Oh, you know why it didn't load? Because we didn't load reg class. So now we can't get it. Now we actually have to load our libraries back in, right? So EX6 wine is loaded in now. And if we plot EX6 wine, that's a bad idea. I just plotted a data frame. I have no idea what that's going to do. Stop. Yeah, that was a bad idea. Yeah, exactly. Red class not loaded in. Let's just crash R. There we go. Now let's run it. What kind of data set are we dealing with, Charlie? What kind of Y variable? What kind of Y variable are we dealing with? What kind of Y variable are we dealing with? As Brian has some quick fun right here. So, what kind of Y variable? I always hate that. Gotta look up the code. We'll worry about that later. A categorical Y variable. Don't worry about all this code right here. It's a categorical Y variable. Very important. You don't have to make these bar plots, so you don't need to include it. I think I learned that during your class too, that block comment, one of my favorite codes right there, the Control-Shift-C block comment, really awesome stuff. So what am I missing right here? Charlie should know this right away. We're predicting a categorical Y. We're missing one thing right here, very important for it. Yeah. Sorry, Jacob. We need the family argument. I'm sorry, Jacob. You're so like, you're like... quality not found. What's going on here with my quality? Oh, data equals. Haha. Haha. Ha ha. There we go. Unexpected, missing a comma. There we go. And add the data argument, right? All these little errors. Oh yeah. Connor's showing how to pull. Well, we wouldn't use reg class. GLM is not in reg class. GLM is a base R function, I believe, right? Or it's under stats, which is a base package inside of R. So Well, so does red class have a GLM? So red class doesn't have a GLM is the stats function right there, right? Yeah, if you and Connor's showing, yeah. No, but Connor is showing also like with that if I go to GG pub R, I can actually get like my GG scatter plot right here and pull it by loading it. No, that's something I didn't know for quite a while too. So if you don't want to load your libraries, you can just go in and grab a function out of a library, and then it'll look through your libraries and grab just that. So that's a quicker way to optimize time to not load in libraries. Like if you have like 50 libraries you have to load in, but you're pulling like one function from each library, then these libraries are just taking time loading stuff up. So you might just call the library and then pull the function from it. So that colon goes inside of a library and says, take this whatever it is, data set or something. I don't know if we could get data sets like that. That'd be interesting. I don't know. I've never tried it. Now that we've got our model written right here, visualize the model with the 2 extra arguments. So you see so this is what Connor's saying right here is you could go to reg class and not have reg class loaded up and go to visualize model. And so now we're calling it from the reg class package. Just good things to know this syntax. You'll see this a lot on Stack Overflow because then someone doesn't have to say, load this library. You just say, take the function from the library, which is what that's doing. The reason we don't have to do that is because we loaded up reg class earlier. At some point in this assignment, we went library reg class, and that loads up everything. So it's already here, and you can tell by going here, and you can see everything I've loaded on right here. It's exactly. Is it in tidyverse? So ggplot2 is a package. So ggplot2 is the library or is the library itself. And so tidyverse is a package too. But so if you want here and went to geom, like any of these right here, does that make sense? So now you don't have to load in ggplot2. You can access all the ggplot2 functions from this. ggplot2 is a package itself though. But tidyverse, you can see what's inside tidyverse. If you go here to tidyverse, and you can see all these things right here. So I've never even used these functions, but these are the functions inside of the tidyverse library that you have access to. So yeah, no, it's a really good thing to know and understand what it's doing when you do the colon. You can go to a library and then colon and get the things inside library. We're throwing down all that knowledge today. This is all the great stuff right here. And let's go xlim. We're just going to copy these. Copy, boom. Delete out that, delete out this. That and turns into a comma. Let's go take a look at this. And what do we see right here? We see 2 sigmoidal curves. 2 sigmoidal curves. In general, what does alcohol do to the probability of a wine being low quality? So if a wine has more alcohol, the probability of it being low quality will do what? No matter what, there's no interaction here on this. There's no interaction. So that means, Rock, when it comes to volatile acid and alcohol and the way it predicts quality of wine, it doesn't matter. Doesn't matter. So the more alcohol wine has in it, the probability of it being low will do what? It lowers the probability of it being low quality. So you've got kind of a double negative right there, which means it would actually do what to the probability of being high quality. So if it lowers the probability of it being low quality, alcohol would do what to the probability of a wine being high quality? So it lowers the probability of low quality wine at all points. At all points, alcohol lowers the probability of low quality wine. And I'm probably going to remake this graphic. I'll show you why. Oh my God, go away. So what I want to point out here, and I'm going to go loc on this. Well, no, we need it actually. We need it. So it lowers the probability of low quality wine. And now I want you to take a look at it raises the probability of high, exactly. If you were to take 2 wines here that are otherwise identical, meaning they have the same alcohol content, but this one's on the blue. Let's go here to 15. This one's on the blue, which means small, and this one's on the black, and this one's on the large. Which of these would have the highest probability of being high quality wine? Now I'm asking this in reverse. Would it be the blue, the black, or the red? Which of these would have the highest probability of being high quality? So you've got the blue, the black, and the red. So irregardless of whatever the alcohol is, when you go across volatile acid at the same alcohol level, would it be the blue, the black, or the red has the highest probability of being high quality? I'm asking in reverse. The highest probability. Black and blue are close, but you can tell right here, if you look at this, the blue is always going to be, because these are parallel sigmoidal curves, the blue is always what to the black. So you're on the right track there, Charlie. The blue is always what to the black. So you could look at any point. The blue is always going to be what to the black. They might start to look close, like even over here they look close, but the blue is always this to the black because these are parallel. Like they're gonna, the curve shapes underneath exactly. So the one with the highest probability of being high quality, which would be the blue, the black, or the red. Like you can go to any point right here, like go blue, black, red. And so which of these would it be? The blue, the black, or the red has the highest probability of being like at any point? So all we're doing is just looking right here. If you go to any level of alcohol, like right here, and you go up, you go blue, black, and you go red. Red's way up here at this prediction. So which of these would it be has the highest probability? The blue, exactly. Now, remember, this is the lowest probability of low, which means the highest probability of high. I think that's where it's confusing because this is saying blue would have the lowest probability of being predicted to be low. Like this is the probability of blue being low quality. And so thus blue would have the highest probability of being high quality. Little bit of like a reversal on what you're seeing right there. So blue would have the lowest probability of being low quality, but also that means highest probability of being high quality. So volatile acid being small is predicted to be higher quality wines. So you see lower values of volatile acid with higher values of, or high probability of being good wine. And you also see the same, we see the reverse with alcohol. Alcohol, generally higher levels of alcohol leads to higher probabilities of good quality. Is this all making sense, Charlie? I know it's a lot to take in, understanding what's going on with this graphic, but does that make sense to say small values of volatile acid would have us predict higher quality of wine, where high values of alcohol have us predict higher quality of wine? And that all goes to understanding these probabilities being predicted from this model right here. So for A2, would we use the graph on the right? I believe so, right? Let me look at what A2 says. Kind of answering through and going through these a little bit right here. Among wines with the same alcohol content, because if you have the same alcohol content, you're just tracing up right here like we were doing. So we kind of answered that one right there because you're just tracing up right here. Does that make sense? Like if a wine has the same alcohol content, you'd be like right here and tracing up, and you'd be like, which one has the highest probability, which one has the lowest? Like same alcohol content means everything else the same. You're on the right track. That's exactly it. Because same alcohol content means like only go to one point right here and just go like trace up, and you'll just see which lines you hit. Because you're just going to go to like one point, say like, okay, we have an alcohol content of 13. You trace up like this, and you say, okay, which would it be, the volatile acid, small, medium, or large? And then up, so they have the interaction. Let's throw an interaction on here. So now all we're going to do, wait for the microphone a little bit, is we're just going to put a star right here. And this drastically changes. So when you look at this plot now, which of these has the strongest relationship? Is it small, medium, or large has the strongest relationship? So which of these wines now has... you're welcome. Thank you so much, Connor. Anytime. You are welcome here anytime, Connor. Like, swing by. We like it, man. Glad to have you as a mod. Connor, if you ever want to be a mod on the Discord, let me know. Like, if you want to... I mean, we don't ask mods really to do anything, but you're always welcome. So you see here, large. You are correct. This is where the relationship is the strongest. And so the prediction here now is like, if we were to say which wine would have the higher prediction, which kind of I think leads into some of the questions, wink, wink. The prediction is not going to be constant because at this point, the blue wines, the volatile acid small, would have a higher probability of low than the red wines right here, the volatile acid large. So the volatile acid large actually go to a lower probability of being low at a point of about like 13 or so. But back here, the blue wines would have the higher probability. Let me check. They'd have a lower probability over here, yes, and then they'd have a higher probability over here. So it's not consistent about which wine on this interaction graphic would have the probability. If you look, the interaction is very significant. That is a ridiculously strong interaction about the changes to the sigmoidal shape. Is this making more sense right here, Charlie, to say like the change to the sigmoidal shape? You can see the p-value over there for the interaction term. We could also get it via summary. And there's that same p-value. It actually is better estimated when we look at the plot p-value. This p-value right here to the change to the sigmoidal shape is ridiculously significant. So we see a change to the shape of the sigmoidal curve to where volatile acid large has the strongest relationship now. And you can't go to one value of alcohol exactly. And you can't go to like 15 because at 15, you would see that the volatile acid large would have the lowest probability, where volatile acid small would have a higher probability. But over here at like 10, volatile acid small has a lower probability, where volatile acid large has a higher probability. So the relationship is not constant because of the interaction. So the way in which alcohol explains the way in which alcohol explains, yeah, the one on the left, because this one's set up differently under different parameters. You'd have to do a totally different zoom. You could actually look at the graph on the left. You'd have to do something like, let's go right here. So it needs to be even smaller. Oops, I messed it up. Oh my gosh. So this, let's go to negative. So this, and there's a huge interaction here. So this is the way in which volatile acid explains the probability of being low quality depends on alcohol. And you do see a major change here. So you could look at this one. You just have to change the Y limbs. So it's still a very strong interaction to where actually volatile acid has a totally different relationship, but this is not the one to interpret. But does this make sense right here, Charlie, that there's such a strong interaction that the sigmoidal curve actually changes completely from a sigmoidal up to where it increases the probability of being low to sigmoidal down where it decreases the probability of being low for high alcohol. So at high levels of alcohol, the relationship volatile acid has with probability is actually it decreases the probability of low alcohol. So very, very strong interaction right here, as seen also by the p-value and the change to the sigmoidal curve, which we are not looking at this one for the problem, but the fact that it literally goes from a sigmoidal up to a sigmoidal down shows us that it changes the way the probability is even being calculated. So you'd have to zoom in differently to see it. You'd have to change the X limbs on those. But yeah, no, Charlie, great job. And Josie, great to see you. I think that's got it. We got 5 more minutes, but I'm going to probably end office hours and we'll be teaching here in 25 minutes. So 201, get ready. Papa Shark, are you ready for class? You got it. Great job, everybody. We'll be back here tomorrow for more office hours, but swing by for class. I'll see everyone in class in 25 minutes. See you then. Bye.